Good morning, Doctor and everyone. We are from Group 1, Section 1. Today, we'll be presenting on our experiment entitled The Effect of Zinc Electrode Surface Area on Electrochemical Activity, which is current in an electrolytic cell. I'm John Lau, and let me start with the introduction part. Electrochemical cells involve redox reaction, where the electrons are transferred between electrodes through an external circuit. In an electrolytic cell, a non-spontaneous redox reaction is driven by an external power supply. In this experiment, we focused on a zinc-copper system. Zinc acted as anode for oxidation, while copper as cathode for reduction. Based on the key theory for this experiment, current is directly proportional to surface area when the current density is constant according to electrochemical theory. And Faraday's law was used to relate current to the rate of redox reaction. The objective for this experiment is to investigate the varying surface area of zinc electrode affects current in an electrolytic cell powered by a DC power supply.
The chemicals used were 1 mole of copper 2 nitrate, 1 mole of zinc 2 nitrate, zinc strips with 5 surface areas of 1 to 5 cm square, copper strip with same size for all tests, and distilled water. The apparatus used were DC power supply, ammeter, connecting wires and clips, beakers of 100 ml each, salt bridge, sandpaper, stopwatch, and ruler. Zinc electrodes were prepared in 5 surface areas of 1 cm square, 2 cm square, 3 cm square, 4 cm square, and 5 cm square. The zinc strips were then labeled and cleaned thoroughly with sandpaper. 250 ml of 1 mole of zinc 2 nitrate solution was prepared by dissolving 60.4 grams of zinc 2 nitrate powder in distilled water in a 250 ml volumetric flask, whereas 250 ml of 1 mole copper 2 nitrate was prepared by dissolving 74.37 grams of copper 2 nitrate powder in distilled water in a 250 ml volumetric flask. 2 100 ml beakers were filled with the solutions prepared for the zinc and copper electrodes. The zinc electrode, which is the anode, was inserted into the zinc 2 nitrate solution, and the copper electrode, which is the cathode, into the copper 2 nitrate solution. The electrodes were connected using a salt bridge, and the DC power supply was connected with the positive terminal to the copper electrode and negative terminal to the zinc electrode. The voltage was set to 1.1 volts, and the ammeter was placed in a series. The setup was allowed to stabilize for 30 seconds, then the current was recorded. The procedure was repeated for each zinc surface area, whereas the surface area of copper was set as constant.
For results analysis, these are the tables referring to current measured and theoretical current. As we can see, current increased with electrode surface area for both tables. From the theoretical current, the rate of reaction also increased as surface area increased. For the graph plot, the results show a linear relationship between current and surface area. This is because more surface area provide active sites for zinc atoms to oxidize, more electrons are released per second, leading to a higher current. Since current increases with surface area, and the rate of reaction is calculated from the current, thus the trend is set. These results align with theoretical predictions and confirm that electrode surface area is a key factor in electrochemical efficiency.
Moving on to the discussion part of our experiment, as you can see from the results, the current increased with the zinc electrode surface area from 0.08 amperes at 1.0 cm square to 0.29 amperes at 5.0 cm square, showing that a large surface area provides more active sites for oxidation, which allows more electrons to be released and increases the overall current. This trend aligns with the Faraday's law, where the electron transfer rate is proportional to the charge passed. So, as surface area increases, the redox reaction rate also increases, meaning more charge is transferred over time. And finally, the calculated electron transfer rate reflects this too, increasing from 8.29 exponent 7 to 30.1 exponent 7 mole per second, indicating more frequent electron movement as more zinc atoms are present. Okay, next I'll briefly go over some sources of errors that happened during the experiment and precautions that can be taken. So firstly, one source of error could be the increase in resistance due to the wires or the setup, which may affect the current readings. And then loose connections in the circuit might also lead to unstable current flow, affecting the current readings. And then next is the instruments might have not been calibrated properly, which can cause inaccurate values. And finally, inconsistent measurements of the zinc electrode surface area could also affect the reliability of our results. So the precautions that can be taken is using accurate measuring tools such as calipers to measure the electrode area, also securing the electrode connections tightly before starting the experiment, and also ensuring that all instruments are calibrated properly before taking any readings.
In conclusion, the objective of this experiment has been achieved. result supports the electrochemical theory of the larger surface area resulting in higher current with voltage remaining constant. Thank you for listening.